Students, today we are going to discuss one of the important topic, that is Faraday's laws. Okay, so take on a notebook and write the important points. Today I will discuss last 24 years of NEET exam questions. So it's very important. So shall we start? Yes. So Faraday's laws. Faraday's laws. So Faraday is known as the father of electricity. He studied broadly about electrolysis process. Can you tell what is electrolysis? Yes, electrolysis is the process of dissociation of the electrolyte into its ions. Suppose I have taken on beaker, in that take any electrolyte. Suppose I am taking copper sulfate. Copper sulfate I took, then two electrodes. Two electrodes, right? Electrodes are nothing but the metal which pass current to the electrolyte. Okay, so here both are I am taking copper, then pass electricity. So electricity here we are using, okay, DC current only using for the electrolysis process. Now passing electricity, what will happen? The copper, from the copper sulfate, okay, copper ions will dissociated into Cu2 plus, and this Cu2 plus will deposited on the negative electrode, that is called cathode. The negative small line, okay, which is attached to the electrode, that is called cathode, and the positive big line, this is anode. So where the copper get, the metals are usually deposited on the cathode. So the copper will get deposited on the cathode, copper electrode. So this process is continuously going on, and the anode will dissolve in the solution, and the solution, from the solution the ion get deposited on the copper. This is electrolysis process. This thing is studied in lower classes. So how much amount of copper will get deposited? That is mathematically explained by Faraday. Okay, so that is called Faraday's first law. Faraday's first law. So what is Faraday's first law? The amount of substance which get deposited or liberated at any electrode is directly proportional to the amount of electricity passed through the solution. Okay, understand? Then study. It is very easy. So what is Faraday's first law? The amount of substance that get liberated or deposited is directly proportional is directly proportional to the amount of current passed through the electrolyte. That means how much amount is depositing. That is based on how much current in how much time you are passing. Represented as, mathematically we can represent it as W is directly proportional to Q, where W is the amount of substance that get deposited, is proportional to Q. Q represents the charge of electron. You studied that Q is equal to IT. One equation is there. I represents the current in ampere. T represents time in second. Okay. So we can give the value W is directly proportional to I into T. We have given the value of Q. That's only. Now remove the proportionality by multiplying a constant Z. Z into I into T. So Z is called a constant, that is called a electrochemical equivalent. Electrochemical equivalent. We can find out the value of Z. Okay, Z is equal to E by F. E by F. So F is called equivalent mass. Equivalent mass of the substance that is get depositing. Okay, it's get depositing. F is called Faraday constant. Faraday constant. And it have the value, if have the value 96487, or which is approximately equal to 96500 coulomb per mole, right? That's the value of Faraday constant. Yes. Then equivalent mass. How will you find out the equivalent mass of a substance? Equivalent mass is equal to its molar mass divided by N, where N represents number of electrons required to reduce the ion. Number of electrons that required to reduce the ion, anion or cation. Okay, that we will discuss in the problem. We will discuss more thoroughly. Right now, we can write the equation. So now, what the value of E is m by n. So Z is equal to m by n into F. Now you got the value of Z. Now put the value of Z in this equation. Now we will get W is equal to m into Z value is m divided by nf I into T. So this is a very important equation we will use for the problems. Okay, so this is the mathematical representation of the Faraday's first law. W is equal to m into I into T divided by nf, where W, from this equation we can find out how much amount of substance get deposited. It's based on the molecular mass of that substance divided by how many electrons required to reduce that one. Then I current, how much current you passed, how much time you passed, and F is a constant for all the reaction. It's a constant, right? So that's about Faraday's first law. Right, one more thing we can discuss, right, is that how will you define electrochemical equivalent? Okay, from this equation we can W is equal to Z into I into T. So we can define Z is equal to W when I is 1 ampere, time is 1 second. That means electrochemical equivalent is the amount of substance that get deposited when 1 ampere of current passing through the electrolyte in 1 second. If you pass current in 1 second, 1 ampere of current, then how much amount of substance that depositing? That is called electrochemical equivalence. So first, so one of the question, okay, yes, we will discuss about a Faraday, right? So we studied that on Faraday is equal to 96500 coulomb per mole. So suppose write one question: how many quantity of This is a question, okay. How many quantity of electricity in Faraday and Coulomb is required to reduce 1 mole of Na plus, Cu2 plus and Al3 plus ions. Al3 plus ions. So this is the question. How many Faraday of electricity is required? So Na plus. So see here, okay, how many positive charges are here? One positive. So how many electrons? So one electron is required to reduce Na. So how many Faraday? So here you take, okay, one electron. Okay, one electron. So you will get a 1 Faraday of electricity is required. So in order to reduce 1 mole of a substance, okay, 1 Faraday of electricity is required. And then Coulomb, how can you write? 96500 Coulomb. Understood. So simply, what is the charge coming here? The case of cation, okay. How many charges is coming here? The case of, can you tell Cu2 plus how many electrons? 2 electrons gives Cu. So how many Faraday? 2 Faraday of electricity, or 2 into 96500 Coulomb is required. Then Al3 plus, how many electrons? 3 electrons will get deposited as Al. So you need 3 Faraday. In Coulomb you can tell that 3 into 96500. This much is Coulomb. So it's important, okay, how to convert the Faraday into Coulomb by multiplying 96500. Then you can get in Coulomb. So how will you find out Faraday? Faraday you will get from the number of electrons. So how many number of electrons? That much Faraday. That much Faraday, okay, you multiply by 96500, you will get in Coulomb. Right? So based on this, in last 20 years, okay, NEET 2 questions are asked, okay, from this topic of Faraday, okay, not from first law, from the topic of Faraday, 2 questions asked. So this is the first question. So first one is a question asked in 2016. The question is, when 0.1 mole MnO42 minus is oxidized, the quantity of electricity required to completely oxidize MnO42 minus to MnO4 minus is. So options also I am giving. Option A 96500 Coulomb. Option B 2 into 96500 Coulomb. Option C 9650 Coulomb, and option D 96.50 Coulomb. Okay, can you solve this question? So first you write the equation, that is MnO42 minus is converting to MnO4 minus. See the oxidation number -2 to -1. So -2 to -1, increasing or decreasing? -2 to -1, actually it is a oxidation number increasing. So it is an oxidation only. So 1 electron is the difference. If in the reverse reaction, it is reduction. So here you see how many electrons, one electron only. So how many Faraday of electricity is required to reduce? So 1 Faraday is required to reduce 1 mole, 1 mole of MnO4 minus, or 1 mole of 1 Faraday is required to oxidize 1 mole of MnO4 2 minus. Now the question is see 0.1 mole, 0.1 mole. So 1 Faraday, 1 mole. So 1 mole, for 1 mole 1 Faraday required, zero point 0.1 mole means, so we have to divide by 10, 1 Faraday divided by 10, how much? 0.1 Faraday, zero point 0.1 Faraday, zero point 0.1 Faraday means 0.1 into 96500, that means 9600 divided by 0.1 means 1 by 10 only. So 10, so 9650 coulomb. That means option C is the right answer. Option C is the right answer. Yes. Right, finished now. Now next question. Another question is, so another question that is asked in 2020. 2020, this question asked the number of Faradays, the number of Faradays required to produce 20 grams of calcium from molten calcium chloride, given that atomic weight of calcium is equal to 40 gram per mole. 40 gram per mole. So this is the question. Options I will give. Okay, option A 1, option B 2, option C 3, option D 4. So this is the question. Okay, if you can do pause the video and do the question, right? Now, number of Faradays required to produce 20 gram of calcium from calcium chloride. So calcium chloride, how it will ionize? When passing current, okay, it will get ionized, dissociated into calcium 2 plus and 2Cl minus. So here we need 20 gram of calcium, right? So in order to reduce 1 mole, so in order to reduce 1 mole of calcium, calcium 2 plus ion, how many 2 plus 2 Faraday of electricity is required to reduce 1 mole of calcium ion. So 1 mole of calcium ion, 1 mole means its atomic weight only, that is 40 gram. So in order to reduce 40 gram of calcium, 1 mole means 40 gram, 1 mole means 40 gram. How much Faraday? 2 Faraday of electricity is required. So in order to reduce 20 gram of calcium, how much Faraday is required? 40 gram, 2 Faraday is required. So 20 gram means 1 Faraday. So 1 Faraday is the right answer. So option A is the right answer. Okay. Yes. So these two questions are asked last years. Now we will solve the problems from the first law of Faraday's law. First law. Faraday's first law, we will do the problems. So before doing the problems from first law, you should remember the equation, that is W is equal to M into I into T divided by NF. Okay. W is equal to MIT divided by NF. Okay, this equation you should remember. Okay, very important equation. So the first question is asked in 2014. Question is how many grams of cobalt metal will be deposited when a solution of cobalt 2 chloride is electrolyzed with a current of 10 amperes for 109 minutes. 109 minutes. Okay. Option A 4 gram. Option B 20 gram. Option C 40 gram. Option D 0.66 gram. Okay, this is the question. So pause the video and then do the problem. Right? So here cobalt chloride. So it is telling 2. So it will associated as C cobalt 2 plus and 2Cl minus. So cobalt 2 plus, in order to reduce cobalt 2 plus 2 Faraday of electricity is required. So number n, here what is that is the value of n 2, not 3. Okay, cobalt will show oxidation state of 3 also, but here we have to take n value 2 only. Now write the equation W is equal to MIT divided by NF. What is the mass of cobalt? Okay, right? Cobalt mass is given atomic weight of cobalt. Cobalt is equal to 59 U. 59 unified mass. That also that will given. Okay, in the question it will be given. So 59 into I. How much current we are passing? 10 ampere. 10 into time. Not 9. Okay, it is in minute. And on the question here we have to give in second only. Okay, right? Second only have to give. So multiply by 60. Right, in second divided by number of how many electrons? So 2 electrons. 2 into 96500. Right? So do the calculation. Calculation you do. The zeros everything you can cancel. Zeros everything cancel. Right? Now 2. This 2 you can cancel. Okay, 3 will come. 3 will come. Right? So you see the values. A lot of difference is there. So you can take an approximate value. See here, yes, here or not 9 3 59 divided by 965. So you multiply these values. Multiply this value. If I am taking 60, suppose it is 60, 60 into 3, 180, 180 into 100, 180, 100, 20 will come. This is I am approximately taking as 1000. So it is coming as 18, right? 18 approximately only I am taking. So 18 it is coming which is near to 20. So 20 gram, right? Yes. So this is the correct answer 20. See, I didn't do any calculation on approximate method only. Usually this also you can use. Okay, when you should use this one. See, The values are very different. 40, 400, like that given means approximation you can take. That's easy. Time saving, a time saving method. Right? Yes, this way you can do that problem. Then next question. Next question is this is asked in 2013. Okay, 2013. This question asked. L2O3 is reduced by electrolysis by electrolysis at low potentials and high current if 4 into 10 power 4 angstrom of current is passed through molten L2O3 for 10 hours, what mass of aluminum is produced? So atomic mass of aluminum is equal to 27 gram per mole. Okay, so this is a question. Options A is equal to 8.1 into 10 power 4. Option B is equal to 2.4 into 10 power 5. Option C is 1.3 into 10 power 4. Option D is 9 into 10 power 3. This many grams. Okay. So what is the right answer? So here also what you have to find out what is the mass. So W only, what is our equation? MIT divided by NF. So mass of aluminum, mass of atomic mass of aluminum 27 into is passed through molten for 10 hours. So hour you have to convert into second. So into 60 minute into 60 second. 10 hours. Time, what is the current? Current, okay. No, and yes, 4 into 10 power 4 ampere is passed divided by number of moles. See here, which is the Al2O3. So Al2O3 only, so aluminium Al3 plus. Al2O3, how it will ionize? 2Al3 plus plus 3O2 minus. So 3 plus will come. So 3 electrons are required. 3 into F is 96500. Right? So see the values, totally different values. So we can take one approximation method. So 0, 0 we can cancel. 3. Here 9 will come. Right, 9. So here 90. So 36. 36. 4. 36 into 4. 4 to 144. 9. 144. So 36. 36 into 4 we took. So into 10, so one more 0 will come into 9, into 9. So what will come? 0, 9, 40, 27, 36, 3, 36, 39, 3, 9, 12 divided by 9, 6, 5. So 1000 I am taking. So how many 3 zeros will come? Yeah. So 3 zeros, 3 zeros. So here 10 power 4 is there. You have to multiply by, so 2 more zeros, 129 double. So this 6 0 I'm giving. Okay, two zeros will come. That means okay, 1 2. Yeah, this we can write as 1.2 into 10 power 4 gram. That means it's almost equal to C. Option C is the right answer. So we are going to do the next problem. That is 2002. It is asked in 2002 question. At a 5 ampere current is passed through a solution of zinc sulfate for 40 minutes. The amount of zinc deposited at the anode is given that atomic mass of zinc is equal to 65.29 gram per mole. Answer option A, zero point 0.4 gram. Option B, 65 gram. Option C, 40 gram. Option D, 4 gram. So, right, so what is our basic equation? Our basic equation is W is equal to MIT divided by NF. So mass of zinc, how much it's given? 65, atomic mass 0.29. The current 5 ampere, so 5 into time 40. So time you have to convert into second, don't forget. So 60 into 14 to 60 divided by number of electron. So zinc is given, so zinc sulfate. How the zinc sulfate will dissociate? ZnSO4 will dissociate into Zn2 plus 2 SO4. So here see Zn2 plus. So two ions are forming and 2 Faraday of electricity is required. So 2 into F value 965. So don't go for higher calculation. You see the options. It's two different values. A lot of difference is there. So you can simply do by like this. Okay. So 2 and 6 3 times 12. 4 into 3 12. 12 into 5 60. So 60 into 65. 60 into 65 divided by 965. Suppose okay, 60 into 60, what will come? It is almost divided by 965. So 965 you can take as 1000. So 1000 divided by 36,000, it is 3.6. So 3.6 value similar to 4 gram. So it's almost equal to 4 gram. So option D. Option D is the right answer. Right. So based on this, a lot of problems asked. So now you understood. So now you understood how will the question is coming. So we will do another type of question. This topic only is asked in 2016. Question is, during electrolysis of molten NaCl, the time required to produce 0.10 mole of chlorine gas using a current of 3 ampere is 3 ampere is right. Yes. So if you see the options, A 55 minutes, option B 10 minutes, option C 220 minutes, option D 330 minutes. So here on difference is there, this much time we did how much you weight. Here they asked the time required. So what is our basic equation? W is equal to MIT divided by NF. Now T you have to find out. So what's our equation? So T is equal to, you can write T is equal to W into N into F divided by M into I. Right? Yes. So time is equal to weight. So how much, what is the weight? So weight is given or not? The time required to produce 0.1 mole. So weight is not given, but a number of moles is given. So number of moles is equal to weight divided by, so number of moles. Here you know the formula, N is equal to weight divided by molar mass. So weight is equal to N into molar mass. Okay, right? So N, number of moles, 0.1 into molar mass. That is here what, chlorine. So chlorine, it is 1 chlorine 35. So 71 will come 71 into. So W we got a number of electron. So Cl2, 2 will come 2 into Faraday 96500 divided by, this is molar mass, that is 71 into I. Current, how much current? 3 ampere. Right? 3 ampere. Now you do this, you will get the answer. The answer you will get in second, but here it is given as minute. So you have to divide it by 60. So when you are doing this problem, give the values, right? So simply we can do cancel the 0, then 71, 71 you can cancel. Here 2 and 6, 3 will come, right? So 3 into 3, 9. 9 will come, so 9 by 9650. 9650 by 9. So 190,605, 65, 7, 63, 220. So 1000, so we'll get a 0.1. So 107.2, which is almost is equal to 110 minutes. Okay, right? So option B is the right answer. So option B is the right answer. Yes. So now we will do another two type of problem also. Actually, it is not directly linked with the first law, but you know, you should know that type of question. And this is the next problem. Is asked in 2016. Question is the number of electrons delivered at the cathode during electrolysis by a current of an ampere in 60 seconds is given that charge on electron is equal to 1.6 into 10 power minus 19 coulomb. So this is a question. So option A 6 into 10 power 23, option B 6 into 10 power 20, option C 3.75 into 10 power 20, and option D 7.48 into 10 power 20. So this is the question. So this question, you have to find out number of electrons, not the weight. So here we have to use another equation. You studied that Q is equal to IT. Q is equal to IT. Another equation also studied, Q is equal to NE. So you get these two sides. So you can write NE is equal to IT. So N is equal to I into T divided by E. I is current. Current is given. Okay. How much current? 1 ampere. So 1 into time in seconds. So 60 divided by charge of electron. That is 1.6 into 10 power minus 90. Right. So 1 into 60, 60 only. 60 divided by 1.6. So you can write 60 divided by this. You can write as what? 16. 16 into 10 power minus 1. See, this 1.6 I wrote as 16 into 10 power minus 1. If you multiply this one, 1.6 only value into 10 power minus 90. So see, 60 divided by 16. So 15 means 4 times will go. Say here 3 point some value 3.7 will come into 10 power minus 1, 10 power minus 19, 10 power minus 20. You take it above, so 10 power 20. So this answer. So option C is the right one. Option C is the correct answer. Yes. Now, based on this, we will do one more problem. One more problem we have to do. The mass of, the question is the mass of carbon anode giving only, in bracket, giving only CO2, carbon dioxide, consumed. So you have to find out the mass of carbon consumed in the production of, the production of 270 kilogram, 270 kg of aluminum metal Aluminium metal from bauxite by the Hall process. Hall process is, so option A 270 kg, option B 540 kg, and C 90 kg, D 180 kg. Right? So this is another type of problem. How much carbon reacted, right, in the production of 270 kg of aluminum metal from bauxite? The whole process is, so you should know the reaction. The carbon will react with the bauxite. What's the formula? Al2O3 will give aluminum and carbon dioxide. Then balance the equation here. 3, here 2. So you have to multiply by 3. 6. 6 oxygen, here 3. So you multiply by 2. Oxygen, first balance oxygen. Now 4 aluminum. So give 4 here, 4 aluminum. How many carbon? 3 carbon, 3 carbon. So give 3. So this is the balanced equation. Now you see 4 aluminum is reacting with the 3 carbon. So 4 mole of aluminum reacting to give 3 moles of carbon. That means 1 mole of aluminum reacts to give 3 by 4. Take this 4 down, okay? Now 4 by 4, or this 4 divided by 4, 1. This 3 divided by 4, 4 mole of carbon. Right? What is the mass of 1 mole of aluminum? What is the mass of 1 mole of aluminum? 1 mole of aluminum, its atomic mass is 27. So 27 gram of aluminum reacts. So right. So 27 gram of aluminum. Therefore aluminum. Okay, right. So 27 gram of aluminum reacts to give 4 by 3 into mole of carbon. 1 mole of carbon. What is the mass? Atomic mass 12. Right. So here, what is the question? 270 kg. Right, 270 kg. So you can write 270 gram of aluminum. 270 gram of aluminum will give 3 by 4 into 12 into, they are multiplied by 10. Right. So what is the answer we'll get? You can cancel here 3 times. So 3 into 3, 9. Right. So 9 into 10, 90 gram. That means 270 gram of aluminum gives 90 gram. That means 270 kg of aluminum react with how much? 90 kg of carbon. So the right answer is option C, 90 kg. Right? So these are the problems related with the first law of Faraday.